purpose of this script in this tutorial is to help you make sense of how to compute with diopters and to make sense of defocus and see some examples. In the first part, we just open up ICED and run the usual initialization code, and then we're going to go create a test scene that we will use for calculating the defocus and blur. We'll add the scene to the database and bring up the scene window, and there it is. I kind of prefer looking at the scene with looking a little less yellow, and so I'm going to adjust the scene illuminant so that it looks a little more neutral and more like a blue sky rather than a tungsten light, which is what it was originally captured under. Next thing, we're going to go and create a optics model, and it's a shift invariant optics model, and then we're going to create the optical transfer function for the shift invariant model, and we're going to create one that's got a defocus of 5 diopters. So the code here, which you can study on your own, the code here sets the defocus, the MTF, sets it, and then computes what the blur would be, and produces an image, and that's what a 5 diopter defocus looks like. If you're somebody who has 5 diopters of defocus, that's what it'll look like, and here's what it would look like in the similar system if you had 0 diopters of defocus. In other words, you were just in good focus. Obviously it would be much sharper. That's 0 versus 5. So the next thing I want to show you is how to think about positioning the sensor inside of a camera with respect to the defocus. So when we have a lens, it's got a focal length and a particular power, and suppose that we make an error, we position it, let's say 10 microns off. How bad will that be? Well, if it's off by 10 microns, then the actual power of the lens will be as computed here. Will correct for the focal length and the error in the distance, and that'll give us some amount of defocus. And we can literally, instead of just using the number, about 0.6, 0.7 diopters of defocus, we can create a simulation of that, and we can put it up on in the scene window to see what the penalty would be, and that's what's shown here. About 0.6, 0.7 diopters of defocus would give you a little defocus, and that's how bad it would be, as shown here in this window. So we can now go and try it again, but in this time, instead of being 10 microns off, we can create it to be 40 microns off. In that case, we run the same calculation. We calculate how much the defocus is. It's going to be about 2.5 to 3 diopters, and the penalty for misplacing the sensor by 40 microns instead of by 10 microns is that much more blur, and so that's very, very serious. And as a result, we can use this kind of a tool to get a sense of how bad things are going to be when we have sensor displacements of different amounts, 10 microns versus 40 microns. We can just calculate from first principles.